know that an EQ allows us to boost or cut specific frequencies, but there are several unique ways that we can do that. We call these different types of boosts and cuts EQ curves. Let's review the most common type of EQ curves. The first most common type of EQ curve is called a bell curve. We call it a bell curve because when we look at the curve on the graph, it looks kind of like a bell. A bell curve is a very standard tool for boosting and cutting frequencies all across the frequency spectrum. This type of curve is a go-to for sculpting and tone shaping a sound. Bell curves are a good way to boost or cut frequencies. For example, we can make this guitar more present with a bell curve by boosting around 2 kHz. So a lot more present sounding because of this bell curve boost. We can also make this synthesizer less muddy by cutting around 250 Hz. So that is the bell curve. It's a very common type of EQ curve. The next type of EQ curve that is commonly found is the shelf. A shelf boosts or cuts all frequencies above or below the frequency that we set, which is called the corner frequency. This EQ type is great for when we want to make broad tonal changes. You can see that it gets its name for the way that it resembles a shelf. For example, we can use a shelf to add a boost to all frequencies below 500 Hz in order to thicken up a sound. Take a listen to this bass guitar and how we can boost all of the low frequencies below 500 Hz. We get a much thicker bass guitar by using a low shelf boost. We can also use a shelf curve in order to tame an overly bright sound by cutting all frequencies above 5 kHz, like on these drums. Really helped to tame out those hi-hats and make them smoother on the top end. So far, we have gone over the bell curve, which is a very common type of EQ curve for precise boosting and cutting to shape a sound. And we've also looked at the shelf curve, which is a more broad way to sculpt or shape the sound. We also commonly find various filter types on EQs. The main distinction between bells and shelves and filter types is that bells and shelves can either be boosted or cut at a certain frequency. Filter types are only set to cut frequencies. Let's review some common filter types. The first two filters that we're going to go over are the low-pass filter and high-pass filter. A low-pass filter lets all of the low frequencies through the filter and cuts out all of the high frequencies. A high-pass filter lets all of the high frequencies pass through the filter, cutting out all of the lows. Take a listen to this guitar as we apply low and high-pass filters. So you can hear that the low-pass filter only lets the low frequencies through the filter, and it makes it sound muffled. The high-pass filter only lets the high frequencies through, and it makes it sound very thin. So that is low-pass and high-pass filters. So what happens when we only let the middle frequencies through the filter? We would have a band-pass filter. A band-pass filter cuts out the low and high frequencies of the filter, allowing only the middle frequencies through the filter. So you can hear that we only get the mid frequencies in this acoustic guitar because we're using a bandpass filter. Let's look at one more filter type. A notch filter is used to selectively and precisely eliminate extremely narrow frequency ranges. This is a great tool for getting rid of unpleasant frequencies or issues with your sound. Take a listen to this in action. We have a snare drum with a pretty extreme amount of ring to it. Let's say we want to get rid of that ring. We can do that with a notch filter. So we can hear that with the notch filter, we're able to completely take the ring out. It's only taking out that very small frequency range. So to recap, let's review the types of EQ curves that are commonly found. We have bell curves, which can either boost or cut a frequency, and they resemble a bell on the graph. These are the most common types of EQ curves. Shelves can either boost or cut frequencies, and they affect everything above or below a corner frequency. Filters can only cut frequencies, and there are different types of filters. Low-pass filters allow only the low frequencies to pass through the filter. High-pass filters allow only the high frequencies to pass through the filter. Bandpass filters allow only the mid frequencies through the filter. And notch filters zero in on a very narrow frequency range in order to cut a specific set of frequencies.